Hello everyone and welcome back to the channel. This is Become an Onchain Analyst Today, part 3. And in this part 3, we'll be talking about the easy transfer tables. So, alright, let's get started. So in general, you can think of a transfer table. There are like two broad categories. One is native transfers, and the other being token transfers. Now, of course, this is in the context of EVM, right? Like Ethereum base, Arbitrum, so forth. So for native transfers, this would always refer to the L1 native token. So let's say if I'm looking at the Ethereum table, so Ethereum core easy, where is it? Native transfers. This would be ETH, right? The transfers would be in ETH. But if I'm looking at an L2, let's say Optimism, which is an L2 on Ethereum, the native transfers table on Optimism would still be ETH because the native transfers table always refer to the L1 native token. And everything else except for the native token would be considered a token transfer. Now, token transfer would then have, can be split into more categories, right? We have, of course, the ERC20 tokens. These are your WEF, your USDT, USDC, and basically almost all other tokens, right? And then you've also got your NFTs, right? And this the most common one would be the ERC721 standard. I don't know, your Azukis, your apes, right? And then of course there are other standards like the ERC1155. If you're familiar with Parallel, like a gaming token, I guess. And then on base you've got the base paint collections, right? So there are different standards, and all this would fall under token transfers. But on flip side, currently how we categorize would be, so if I go to Ethereum, if you look at easy token transfers, if you read the documentation, it specifically says it does not contain the 721 and 1155 standards. And so the token transfer table for now only consists of ERC20 tokens. Okay, and for the other standards like 721 and 1155, this would be under the easy NFT transfers table. So where is it? Oh, it's here. Under the NFT schema, and easy NFT transfers. So this would contain both 721 and 1155. So understanding this structure would help you to know which table to reference when you want to, depending on what you want to look at. Okay, all right. Let's look at the native table first. Let's see, where is it? This one. Okay. So I'm just gonna do a select all from and then limit 10. Of course, you can also click on the table itself and then you'll see all the columns here. But I'll just walk through with you what columns are available. Let's see. So I think what's important to know is that there is a origin from address and there is a from address. So what's the difference between these two? So imagine you are maybe I'll draw it out here. Imagine you are Bob, right? This is you, Bob, and you interact with a contract called contract A, and contract A is designed to send ETH to two addresses, right? Let's say it is designed to send to Alice and I don't know what's another name, John. Okay, so you are Bob, right? This is you, and you interact with contract A, and you want to send ETH, and this contract A is designed to send ETH to two addresses, which is Alice and John, right? And so the origin or the columns with the origin prefix means the original sender and the original contract that initiated the transaction. So in this case, Bob initiated the transaction with this contract, and so origin from address will be Bob's address, and the origin to address would be contract A, right? And depending how contract A is set up, it could be like the way this transaction will execute. Maybe contract A sends maybe Bob sends to A, right? And then A sends to Alice, and then A sends to Bob, right? And so your origin from address will be Bob, origin to address will be contract A, and then because there are three sort of if transfers here, there will be 3 rows over here where the from address and the to address would represent each rows each transfers sender and receiver. So you can imagine the first row, the from address being Bob, to address being A, and then the next row, from address being contract A, sends to address Alice, right? From address A, and then to address Bob. Now this is not usual, right? But I feel like this example is helpful to think about how you would use origin from address and when you would use, as compared to when you use the regular from address and to address. Now I would say 80% of the time you'll be better off using just the from address and to address and just ignore all the origin related columns. Okay, if you're just looking for transfers in general, ignore the origin prefixes and just go straight to the from address and to address and amount columns. Okay. Alright, so the next column will be amount. Now if you're confused like what is the currency or what is the denominator of this amount, you can either look up the transaction hash on the block explorer, in this case Etherscan because I'm on Ethereum, or you can also just look at the table name. It's native transfer, so it must be the L1 fee, L1 token, which in this case is ETH, right? And then amount precise raw is really just a like an amount that is unadjusted in its precise format, and the amount precise is of course the adjusted version. Now for like 99% of the time you will not use these two columns. Just stick to amount, right? And then amount USD is just the amount, which is in ETH, multiplied by the price of ETH at this particular hour, and it gives you the amount USD. I think that's pretty much it. So what's important for you to know here is just timestamp, transaction hash, from address to address, amount, and amount USD. Okay, so I would say you can safely ignore the origin from address, origin to address, and also function signature, unless you've got a very good reason why there's a specific filter for this. For example, you want to know how much ETH is sent to contract A in this case, right? I want to know like contract A specifically, right? Even though there are other ways to transfer ETH, but I want to know how contract A, the stats on contract A, and so that's when you would use the origin to address. Okay, but anyways, so these are the columns you would need for ETH transfers. Let's run this and get some examples. So here, paste it on Etherscan. Okay, so this looks like a very straightforward example where this address is just sending ETH to this address, right? Yeah, that's pretty much it. This whole transaction. And so yeah, from address being the sender to address being the receiver, the amount being the amount adjusted to its right decimal places, and then amount USD is the amount. And what else? Let's see. I think that's pretty much it, right? So that's native tables for you. If you look at, like Arbitrum is an L2 for Ethereum. So again, if you're looking at native transfers, it will be ETH transfers on Arbitrum. Okay. What are the use cases for the native transfers table? So one example could be looking at how much ETH a contract on an address has received. So for example, you want to know, like, let's say your question is how much ETH in royalty revenue, how much royalty revenue in ETH was received by the Pudgy Penguins, I don't know, treasury, right? So whenever someone buys a Pudgy Penguin from the NFT marketplace, a small amount of ETH or a percentage of the sale goes to the treasury, which should be the royalty collected for that sale. And so we can track how much ETH was sent to that treasury, right, using the native transfers table. And so I'm just gonna do a quick query to find out what is the address for Pudgy Penguins royalty address. So this is how I would do it. But so this is unrelated to transfers, but this is how I would try to find the royalty addresses. Select transaction hash from ethereum.nft.nft sales, where NFT address is and platform fee 1.0. And then Pudgy Penguins, you would just have to find the contract address over here. Pudgy Penguins, there you go. Oh, sorry, not platform fee, creator fee. So I'm just looking at the NFT sales table where the NFT transacted is a Pudgy Penguin and there is a creative fee of more than 0. Okay, so it's between these 3 addresses over here. So I'm gonna get another sample and see what's this? Oh, this is Wyvern. Let's look at a more recent transaction. What's this? Okay, so let's see, 1A97. Create the fee, right? Huh. This is a buy. 1AF. I think it's supposed to be this, but it looks like they changed address. So this is how I would find a contract as an address. Yeah, it looks like this is the address, or one of the address. And if I go to internal transactions, I should see all. Yeah, looks like this is one of the address. Yeah, okay, so this is one of the address. And let me try to see what is this then. I feel like this is the creator fee. Fee sharing setter. Okay, this is looks rare. Yeah, looks like this is the old address. Cool. So we found. Seems like there are at least two addresses where the royalty there are at least two addresses where royalties are sent to. Right. We have this address over here and an address over here. So you can use both addresses, but I'm just gonna use the latest address just to see, right? And so how your query would look like is, for example, where transaction hash equals to this, right? Sorry, this would be where to address. Yeah, there you go. So I found this is the latest Pudgy Penguin royalty address. And so let's try to verify that. So I'm taking this transaction hash, and there should be 0.0205. Yeah, there you go, 0.0205 in royalty sent to the royalty address for Pudgy Penguins. Alright, so what can we do with this? So of course you can do a time scale, something like cast this as a date, so day, and then sum all the amount. So this is like amount in ETH, right? Group by day. Ideally you want a block timestamp filter here, but I don't think there are many rows, so we'll just let it do a table scan. And if I were to create a graph out of this, let's see, I guess bar. Okay, right, so you can see it's very sparse. So this is telling me maybe the daily view isn't that good. But yeah, on some days it receives a lot of ETH. Right, so what have I done here? So this is just this query, using the native transfers table. You can look at ETH transfers to a specific address. In this case, I've chosen it to be the royalty receiver. You can of course choose any other address. I would say this is helpful for when you want to visualize like how much ETH has been received and sent. Yeah, I don't know. You tell me what other use cases that would be good for the easy transfers table. But yeah, so this is how we would use the native transfers table. Pretty straightforward, I would say, right? You can of course, if you want to be fancy and include multiple addresses, you can do like where to address in, and then you include your other address like this one over here, and then and you want to show like another column, right? So here I have group by day and to address and amount. So which means for each day there will be two entries, which is how much ETH has been received by this address and how much ETH was received by this address, right? So that's what this query is doing. And of course you can consolidate this to month instead of day, so something like date trunk, month, block timestamp, right, as month. And then this would tell you again for each month how much did this address receive and how much did this address received. Alright, cool. So I'm just gonna comment out this, and let's move on to the token transfers table. Okay, so again, we've covered native transfers, so let's talk about token transfers. So token transfers at this point in time in the table refers to ERC20 tokens. So again, these are your WEF, your USDT, USDC, right? And so let's see how are they represented. So again, select all from for this good practice, include a timestamp filter here, right? Could be anything, right? So the easy token transfers table will only contain ERC20 tokens. So we have a yeah, again, your origin from address, origin to address, which if you go back to the example of the contract, Bob sending to contract A, right? It is the same thing here, right? I should probably include that example, right? Maybe I'll just include it again. So Bob sends to contract A, right? And contract A is designed to send, let's say, USDC to Alice and John. So your from address would be Bob, to address would be contract A, and then your from address here would then be contract A, and to address would be Alice and John. So really, because you want to know who received, which is Alice and John, you really should just be using the from and to addresses. And so let's say it admits, several things. So event 1 could be Bob sends 10 USDC to A, or contract A. And then event 2, contract A sends 5 USDC to Alice. And then event 3, contract A sends 5 USDC to John. Okay, so this is your from address, and this is your to address. And again, we have some amount columns, right? The one that you would use the most is, of course, the amount column, right? For popular tokens, of course, you can use the amount column, but if the decimal column here is null, then you would have to find the right decimal places and convert the raw amount to its right decimal place. And the amount USDC is, of course, the amount converted to USDC. Yeah, you've got the symbol, token price, right? So yeah, really what's important is just a few things, right? Not that many. So again, timestamp, transaction hash, from address to address. I guess a special thing that we'll add here is the contract address column, because we're looking at the token transfers table, there could be a multitude, there could be a lot different types of tokens, right? So contract address is our token address, and we're including that here, and our amount. Okay, another thing to note is that because I wouldn't recommend using the symbol column to filter, because one, we might not have the symbol, the contract might not have a symbol, right? The way we get symbol is we do a read on the contract, and if it does not have a symbol, disappear as null. Instead, use the contract address as your filter, right? Yeah, so I'll show you how to do that. So let's say we want to get USDC's contract address. So I would just type in like USDC, and then try to find like what is the most popular. Like in this case, there's like a verified button over there by Etherscan, right? Just look at the holders, right? This looks legit, right? So this would be your USDC. So end contract address in, and then this would be USDC. let's say I also want USDT, right? Again, looks good. Alright, so USDT, maybe DAI. DAI. Right, okay. USDT. Okay, so I'm fairly certain that all these three contracts have symbol have a non-null symbol, so you can use the symbol column over here, right? Symbol. But in the event where it is not labeled, and you would like to label it yourself, you can always do something like case when. So case when, right? Something like when symbol is null. Oh, sorry. When contract address is this, then label it as USDC, right? Let's copy this. And then when the contract address is this, I'm labeling as USDT, and this is DAI. Again, check if the symbol column already has these symbols, right? Most likely they do, but if they don't, this is how we would do it. And then just end as symbols, right? Right, so that's pretty much it for the token transfers. And the reason why, and one, I guess one use case for the token transfers is just to see like how much of these stablecoin transfers, like the comparison between these three stablecoins and how much of it has been transferred. So what I would do usually is so what I'll do usually is I'll just make it like a raw table. So with raw as, the idea of this raw table is that this holds all the data that I want, right? Holds all the filters I need, which is the timestamp, which is the contract addresses that I'm interested to look at. And then in my final table is where I'll do the manipulation and aggregations. So I can do whatever I want here, right? Maybe for instance I want to see like on a month to month comparison how much of these stablecoins was transferred, right? So maybe something like symbol, then sorry, I need a timestamp here. So date trunk, and then sum the amount. So as monthly sum, monthly amount, and then it's grouped by all. So what this does is it tells me for each month and for each symbol what is the amount transferred. It looks like there's a lot of stablecoin transfers. So let's try to visualize this. So month, symbol. Sorry, this would be monthly amount. How do I delete? What's this? Okay, and then of course, grouping field is symbol. That did not work. Why? Am I supposed to choose a different chart? Bar stack, maybe? Bar line. I guess bar stacked. Okay, so month, amount, symbol. There you go. Okay, so this tells me for each month how much volume of transfers did each stablecoin do. Yeah, I mean the numbers looks very high. So did I use the correct? I did use amount, which is correct. Yeah, it looks like here is like in the in the magnitude of billions, 270 billion, right? For this month. Doesn't look right. um, so the way I would troubleshoot this is I would look at each specific contract. So let's just say I'm just looking at DAI only, and then I am filtering by transactions, and I'm looking at each transaction itself and see whether the amount makes sense. Right? Maybe this makes sense because there's a lot of like quote unquote wash transfers. Like I'm sending it to Alice, and then Alice is sending it back to me, right? So maybe that's why the values are inflated. But if you're just comparing if you're just comparing raw sending, this should be the right values. Now, of course, another caveat here is that I have no filters in the to or from addresses. So this is like, you know, usage across the whole space, which is obviously inflated. So you might want to add more filters here to to narrow your findings, right? For example, maybe you get the Pudgy Penguins royalty address and see how much royalties in tokens did it receive. Okay, but other than that, yeah, this is how you would use the token transfers table. Again, token transfers here just refers to the ERC20 tokens, and this is how you would use it, right? Use the to and from address columns, not the origin columns. Use the contract address filters, right? And then check if they have got the symbol. If not, you can just add it in manually like so. Okay, so I'm going to comment out this thing again. And the last but not least, the easy NFT transfers table. Now, the easy NFT transfers table consists of two types of standards, the 7-to-1 standard and the 1155 standard. Maybe I'll just do a quick intro if you're not familiar. So if you click on the NFT collection, right, let's say Pudgy Penguins, it does say the standard here, in this case ERC 7-to-1, which just means for each token ID, there's only one copy of it. And so every token ID is unique in that sense. Or every Pudgy Penguin is unique in that sense. Compare this to something like I think the easiest example is the base paint example. So let me just find it. This one over here. Alright, cool. So for ERC 1155, there is a token ID, but for each token ID, there can be multiple copies. In this case, you can imagine the day 323 as each token ID, right? And then for each of the token ID, you can see there's a number over here, the top left of the, I cannot hover over it, but if you can see this says 3359, this says 486, this says 616, at the top left of the picture. And so that's how many copies of this specific token ID. So for token ID, whatever this is, there is 616 copies of it. And so that's the difference between the 7-to-1 token ID with the 1155 token ID. Standards. Okay, so again, let's look at the NFT table. Transfers. Alright, so we've got timestamp, right? Transaction hash. Let's see. Okay, so I guess the important ones here will be the NFT address, which in the token transfers table is your equivalent for contract address, but in the NFT table it's just called the NFT address. Project name, which is like the symbols. The token name, in this case the NFT collection name, if any. And then NFT from address and NFT to address are your from and to addresses, token ID, which is the token ID that you've seen earlier here, right? And then ERC115 value would just be the copy, the number of copy of the tokens, and it only applies to NFTs of the 1155 standard. So what value would this be? So imagine I were to mint this NFT, and I mint 2 copies of it in one transaction, right? I mint 2 copies. The token ID would be whatever token ID that I just minted. The ERC1155 value would be the number of copies I minted or transferred in this row. Okay, so that's how you would use this column over here. Most of the time you won't. Yeah, and then event index is the index of this particular transfer of this for this block. Yeah, so let's go through some examples. Let's see. Where block timestamp is more than okay, so we've got some examples here that might be good. So one is this, right? So the first example looks like this transaction sends a bunch of NFTs to another address. So let me just keep this here, and I'm gonna copy this here, right? And tx hash is this. Now if you look at Etherscan, there are 9 ERC721 tokens transferred, so we should have 9 results over here, and we do. We have 9 results, and we can arrange this in ascending order, which just means the order in which they are sent. NFT address being the NFT address, right? And then project name being the name of the collection, if there are any. In this case, there is. It's called San Fran Tokyo Genesis Pass. And then NFT from address would be then this address to this address over here. Notice how it is not the origin address. Sorry, it is not the origin to address, right? It is the from address and to address over here. Yeah, so this guy sent like 9 NFTs to this address, and here are all the token IDs that are sent. There is no ERC1155 because this is an ERC721 token, and so there is no 1155. Right, so this is a typical transfer example. Now in NFT transfers, NFT mints, right, a minting event is also considered a transfer, because whenever you mint something, you're transferring from a null address to a known address. So a null address is, it's the, and you might have seen this, it starts with a 0x, and it's a bunch of zeros, right, like this, and we can filter that by using the event type. So something like this address over here. So it looks like, so event type is mint, so you can use this column, this value to filter for minting events. And if I were to scroll this and go to the from address, you would see that this is coming from the null address, as we will call it, or the burn address. Right, this bunch of zeros. If I were to look this up on Etherscan, let's just see what that looks like. Here it shows a ERC1155 token is minted. Actually, this is a great example because it has a value as well. So yeah, an ERC1155 token is minted. It comes from the null address, to this address, this 373 address. So in the data, it comes from the null address to the 373 address. The token ID is this over here, right? 6277 whatever, which is here. And then ERC1055 value is the number of copy, right? Or the quantity of the number of copy of this specific token ID that is transferred. In this case, it's some ridiculous number of like 5, I don't know what's this, billion or trillion, right? And so that value is reflected over here in this column, right? When is ERC1155 used? It is used in some collections like this, where it makes sense to have multiple copies of the specific token ID. It is also used in Uniswap v3-like dexes, where every position of your liquidity is minted as an NFT. In this case, this looks like it's what's happening here, right? So yeah, they mint your position as an NFT, and so that's why you got all these very long, very weird numbers. But yeah, that's how it is reflected in the transfers table. So again, transfers table contains both mint and your regular transfers, because mint or NFT mints are transfers. And the way you would filter them is you would just say where the NFT from address is this null address over here, right? 0x00. Or you can just say where event type is mint. Now, one cool thing about the property of NFTs is because especially, I mean, just for 7-to-1s, because you know that each token ID is unique, right? This token ID is unique, 803, 554. There's only one copy of each token ID. You can write a very simple query to get the latest holders for a specific NFT. So let's say I am interested in the Pudgy Penguins NFT, this one over here. So I'm gonna write a query to get me the latest owner for each token ID. So NFT address is this. I think we have to remove the timestamp. Actually, no, we're fine. And then I just want the to address and token ID, right? So if I just query this, this gives me, you know, any random NFT transfers where, oh sorry, the column name is called NFT to address. Oops. Yeah, any random NFT transfers where it is a Pudgy Penguin transfer. It occurred this year, and yeah, just give me the to address, which is the receiver address, and the token ID. Now you can do this fancy I forgot what's this called, function. Let me just write the full function first. So partition by address, or in this case you don't have to partition by because I already filtered it here, or there's only one NFT here. Order by block timestamp descending, still one, and token ID. Yeah, that looks right. So what this means is I'm creating a new column called row number, which starts from 1 and it counts up on 1 to, you know, whatever. And I am creating this, I'm starting this sequence of numbers starting from 1, and I'm restarting the sequence every time it hits a new token ID. So let's say for token ID 1, right, all the NFT transfers for token ID 1 would be in the same list, right, of counting, you know, 1 to however many transfers. But because I'm saying I'm ordering the block timestamp to descending and it goes to 1, which means I'm only getting the latest transfer for each token ID. And so what this query does, or what this line does, is essentially just saying just give me the latest transfer for each NFT and each token ID. And because each token ID is unique, the latest transfer means the current owner, actually, right? The current owner of this token ID. And you can only do this with 7 to 1. So let's say you want to expand this further and say, okay, we know which address is holding which token ID. What about which address holds the most token ID? So you can just say something like select raw NFT to address and just count 1, which just means count the number of row where it appears. So let's say this address appears twice, right? It has 2 different token IDs, which means it owns 2 NFTs. Sorry, it owns 2 Pudgy Penguins. Pudgy's owned. Just to give it a name. And then if I were to in descending order, yeah. So yeah, this is the distribution of the owners for Pudgy Penguins, right? The most address owns 349 penguins. This could either, you can look this up what this address is, right? This could be a multi-sig, this could be the treasury, or this could be the I guess a whale owning a lot, someone who likes penguins a lot. And we can also compare this to the holders tab. Let's see if I can find the holders tab. There you go. Now note that the values might not be 100% same because there is a small delay in the table, right? With what's over here, this is real time. And so we see that the 294 address is a address by the Blend contract, which is an NFT lending contract by Blur. And then yeah, whatever this address is seems to own a lot. 3F2. Yeah, there are some addresses here which should be here, but I'm not sure why it's not showing. I must have done something wrong here. Let's see. I don't know, I'm not seeing it. I'm not seeing it right now, but this should give you the current holdings, or sorry, the current distribution of ownership. Of course there's a time difference, but yeah, not quite sure. But yeah, that's one use case of the NFT transfers table, which shows you who owns the latest NFTs. Let's see what else. So I guess another use case is because you know who owns how many, you can do like a distribution and say like maybe if you own 1, call it as 1. If you own like 2 to 10, call it as another bucket. And so you can do like a distribution analysis and say whether or not this community holding this NFT, how distributed it really is, right? You can do something like that. And yeah, I think that's it for the transfers. So again, there are, that's how the transfers are broken up into, right? Different categories, and that's how you would use the different tables: easy native transfers, easy token transfers, and the easy NFT transfers. That's all for the video. Thanks for watching, and I'll catch you on the next one. Bye.